I'm given 4 complex numbers here, and I'm asked to perform the indicated operations. My final form is supposed to be written in the format a plus bi, and even if the instructions didn't tell me that, I would still write my final answer in that standard form of a complex number, a plus bi. Well, before I start working with these complex numbers, let's just take stock of what we need to do. So I see that I'm multiplying these two and then taking away the product of these two. So I need to multiply and then subtract. But I actually want to start by thinking about these two. I know I'm going to need to multiply them together. But these two are a special kind of complex number. They're called complex conjugates. Any complex number in the form a plus b, the complex numbers a plus bi and a minus bi are always called conjugates. The only difference is the sign on the imaginary part. And a neat thing about complex conjugates is they multiply together very nicely. So when I go to multiply these together, a times a is a squared. A times minus bi is a bi minus abi. On the inside term, I'd have plus abi. And this is the nice part. Those cancel, and I have minus b squared I squared. Well, we know I squared is equal to minus 1, so this is really just a plus b squared. Whenever I'm multiplying complex conjugates together, I can go straight from the product to the answer because I know it's always a squared plus b squared. So, for this set of complex conjugates, I know I'd be able to do the multiplication just by writing down a squared plus b squared. So I know I'm taking that part away. A is 2, b is 1, so I have a squared would be 4, 2 squared, plus b squared, well, that's 1 squared is 1. So I'll just be taking away 5. All right, so now let's multiply these complex numbers together. And this time I really will need to think about distributing. 8 times 2, that's going to give me 16, minus 8i, plus 18i. And then finally I have minus 9i squared. And every time I see that I squared, I know it's the same thing as multiplying by minus 1, so this is really a plus 9. 9 and 16 would give me 25. Minus 8i plus 18i, that gives me a 10i. And I'm really just taking away 5. 25 minus 5, I get 20 plus 10i. And there's my final answer in that nice standard form of a complex number.